Okay, in this video we're going to review graphing radical functions. Okay, and in this example here we have what we call the parent function because nothing's being added or subtracted to it. It's just the basic function. So whenever we have radicals, if you don't have a graphing calculator, you're going to have to plug in values for x and get your y value. And I would suggest that you use numbers that are perfect squares so we don't have messy decimals. So in this case, if I start with 0, the square root of 0 is 0. So I would mark that. The square root of 1 is 1, so we mark that. And then my next perfect square is 4. The square root of 4 is 2. So when I'm 4, I'm at 2. And then my next one would be 9, so the square root of 9 is 3. So I'm a little bit off the graph, but I get some idea of what my graph is going to look like. So that is the square root function. In the next example, we have something going on in the radical. Remember, our basic function of this is x minus h plus k, where this is my horizontal translation, which way we move horizontally. Remember, he's a liar. K is my vertical translation, and he tells the truth. Okay, so keep that in mind, that K is vertical and it tells the truth. So I notice I'm only having horizontal translation here. I'm not moving up or down any. So we always want to start where the value is going to be 0. So if I look at my value under the radical, if I know if I start with negative 2, that's going to give me negative 2 plus 2 under the radical is going to give me 0. So the square root of 0 is 0. So then if I go to negative 1, again, negative 1 plus 2 is going to give me 1. The square root of 1 is 1. So if I kind of keep with that thinking going forth, the next number I can look at would be 2, because 2 plus 2 gives me 4, and the square root of 4 is 2. And then the next one I will look at will be number 7. When x is 7, 7 plus 2 gives me 9, and that would be 3. So now I have some points to plot. So at negative 2, I'm 0. At negative 1, I'm at 1. At positive 2, I'm at 2. And at 7, I'm going to be up at 3. So that gives me some idea of where to graph. Okay, so remember that you always want to start where this value equals 0. If it's underneath the radical, you're moving horizontally. He's a liar. But if you're adding at the end, it's going to be up and down. Okay, let's look at another example. Okay, on this example, I notice that I have not only, I don't have anything under the radical, but I have on the outside and then something multiplying. So we're going to want to make our table of values. Okay, so I draw the table of values, and I'm going to start where x equals 0 because there's nothing going on in here. So that would give me negative 3 plus 3 times the square root of 0, which is 0, so I'm going to be at negative 3. Then I'm going to go to 1. So negative 3 plus 3 times the square root of 1, that's going to be negative 3 plus 3, so that's going to be 0. So I want to think about my next perfect square would be 4. So negative 3 plus 3 times the square root of 4. This is going to be 3 times 2, which is 6. 6 minus 3 is positive 3. And the next one we would look at would be 9. So negative 3 plus 3 times the square root of 9. That's going to be 3 times 3 is 9. Minus 3 would be 6. And that's all we're going to be able to graph because our graph doesn't go up any higher. So if we have our points, at 0, I'm at negative 3. At 1, I'm 0. At 4, I'm 3. And at 9, I'm going to be at 6. So it's going to be about right there. So if you look at it like this. Okay, if you notice, this graph is increasing a little bit faster than the other two that I've graphed. And that's because of this number out here. Okay, we would say this is a vertical stretch because it's increasing faster. If this was a fraction, it would be a shrink, okay? So since this is it's a stretch, and we move down 2. So if we asked you about the translation, this would be a vertical stretch, and you went down 3 units. Okay. Let's look at the last example here. Alright, I notice I have 2 translations. I have a horizontal and vertical. So let's start with our table of values. Okay, so our table values I've drawn here, we're going to start with what value makes this 0, because we can't have a negative radical, so that's going to be our starting point. So if I start at x equals negative 6, that's going to give me 0 under the radical, and then 0 minus 1 will be negative 1. So let's think about our next perfect square. The next perfect square I could do here would be 4. So if I put a negative 2 in here, negative 2 plus 6 is going to give me 4. The square root of 4 is 2. 2 minus 1 is 1. My next perfect square would be 9. So if I shoot up to 3, square root of 3 plus 6 is going to give me 9. Square root of 9 is 3. 3 minus 1 is 2. Okay. So let's graph that and see if we got enough here. So at negative 6, I'm negative 1. At negative 2, I'm positive 1. And at positive 3, I'm positive 2. Okay, so we can kind of get a graph going like that. Alright, so remember when we have underneath the radical sign, it's horizontal, vertical. So this here we would just say there's no shrinkage or stretch, and you've moved left 6, down 1. Okay? Alright, so this is the review for graphing radical equations.